Hello, my name is James Watson. Here's my email address in case you'd like to talk to me about the contents of this video. Today I'd like to cover arithmetic in C++ and also assignment. So eventually you're going to be writing a program that does some math, that performs an algorithm of some sort, so you don't have to do that math. Math in C++ happens in the way that you would expect, including the order of operations. So I've listed the order of operations here in C++, an incomplete list, but includes most of the operations that you will care about in this class. Expressions in parentheses are evaluated first. Next is increment and decrement and array access, which we'll be talking about later. Multiplication and division, modulo, addition, subtraction, bit shifts, logical operators, and assignment. So the green text is the regular math operations. The blue text is specific to C++ only. I thought it would be useful to just juxtapose C++'s order with the regular math order that you're used to. So if we were to look at, just a regular math expression, 2 plus 3, the quantity 2 plus 3 times 8 minus 5, that'd be 5. And if you were to evaluate this in C++ and assign that to this integer variable result would then hold 35. Nothing strange happening there. And so if we were to use variables in a math expression, which we will do often in this class, then their value is substituted where the variable name appears. And you can use variables in a math expression, provided that the type of those variables, the data type of the variables, is compatible with the type of the expression. And so I've declared some silly variables here that I've named my variables the English equivalents of these numeric values. And I've just substituted them in, I've just arranged an equation exactly like that above, but with these number name variables. And so as this expression is evaluated, the variable TWO will be substituted with the number 2, and so on and so forth. And you would get the same result. Result would still hold 35 as a result of this expression, which after the substitution is identical to this one above. You can also put function calls into a mathematical expression. I'm not sure if in this point of class you've covered functions, but let's just say that we have a function that as its only purpose is to return the integer value 8. And so if we were to invoke that function or call it in the place of that variable 8, that as C++ gets to that part of the expression, this function gets called, it gets evaluated, and that substitution of that return value happens. And result will still equal 35 as above. Next topic is about assignment. This is assignment is pretty straightforward. Basically, once a variable is declared, you can assign any value of the appropriate type to it. It seems pretty straightforward. There's some tricks and trip-ups here that we want to be aware of. And so and as I was alluded to above, that variable will hold that value. This variable name is now an alias or a stand-in for that value for the rest of the program until we assign a new value. So the same name slot now has a new value in it. And so that assignment happens in syntax here. We have variable 1 equals 37. We're assigning it. And so if we were to print out that value, it would show 37, not 31. As I was saying, the value is 37 here. We can assign to it again, and every time that we access that variable name after that new assignment, it's going to be 49 because we just assigned 49 to it. So something that trips up students is the difference between the assignment operator and the equality operator. So the one singular equals character is the assignment operator. Now, even though in mathematics we use that to signify mathematical equality, that's not what this is. In C++, we use the double equals to test for equality, which is, as you'll learn soon, an expression that will return true if two quantities are equal. We don't have to worry about that now. We just have to know that assignment is a single equals a character here. And so it's possible to declare and assign a variable in the same statement. This is called initialization, and it's the preferred way to create a variable, that it just starts right off the bat with some value that we expect. We may want to initialize it with 0 or some number that represents the beginning state of whatever this variable represents. And so why is this preferred? Because when we create a variable, it begins with a garbage value that can't be predicted. And so when we create this float var here, for example, when I ran a program, which hopefully I can make available to your instructor, but if not, just email me about it. When I started up this program and ran this line of code here, that right off the bat, when I created var3 and printed its value was negative 470 million. Why? It's just a random value. You can't predict it. And so just like in the assignment, I'm sorry, just like in the arithmetic section that we just discussed above, is that we can use any expression to initialize a variable, assuming that it's the appropriate type. So it could be a long mathematical expression that includes other variables. It can include function calls. So if I'm creating this float variable, I can assign to it any float expression. So another important thing about assignment is that we want to keep in mind that the right-hand side is evaluated first. So the entire right-hand side of the expression is evaluated before we get around to assigning that right-hand side result to the variable name on the left-hand side. That's important when we're when we're using some variable, modifying that variable's value and reassigning to the same variable in the same statement. You can do that as long as you keep in mind this order of operations. That's why in the order of operations that we talked about earlier in this video had assignment last, so this order of operations could take place. For example, we're calculating the circle area of a circle that has a radius 4. Likewise, if we had a function named area of circle and we passed it some radius, that because we're evaluating that right-hand side first, that this function will do its calculation before assignment happens first, because it's on the right-hand side, and then you can just imagine the information flowing from right to left there. And so for to print out circ area after each of these assignments, then we could just print out the different values. So something that isn't really present in math, regular math, is this idea of compound assignment and increment and decrement. So, but there's some useful patterns, or I guess you could call them idioms in C++, and syntactic conveniences having to do with math here. So let's assume we have some quantity on 1.5. We have a variable called quantity, and we want to add to that quantity the value 3, and just keep that increased quantity stored in that same variable. So this is valid here. So keep in mind, if you see this, when we see this expression here, quantity equals quantity plus 3, that the right-hand side is going to be evaluated first. So at this point in time, on the right-hand side, quantity still has the value 1.5. So that gets substituted right here. And so that substitution is made by C++. So now we add 1.5 to 3.0, get 4.5, and then this assignment happens. This resultant quantity 4.5 is assigned to the variable quantity, which now takes on that new value. So that order of operations is important. So we can compress this expression quantity equals quantity plus 3 with a compound assignment operator, which does two, and plus equals is a compound assignment operator. And so this expression right here, quantity plus equals 3, means assign the quantity plus 3.0 to the back to the variable name quantity. And so just to be explicit here in the steps that's happening, we're performing the operation of the first character in the compound operator as though the left-hand side were the first operand and the right-hand side were the second operand. So that means quantity plus 3.0. And then we're assigning that result to the variable name on the left-hand side. And these compound assignment operators exist for all of the major math operations. So plus equals is just as we discussed. Minus equals it follows the same pattern that we're subtracting a from q and assigning back to q. Same, and the equivalent happens with multiplication and division. The only tricky one here, I think, is the modulo equals, where we're dividing q by a and assigning the remainder back to q, not the quotient. That would be the one above it. Also, something you'll be doing very often, especially as it pertains to loops, is adding 1 or subtracting 1 to some variable, assigning back to that variable. So a plus plus here is equivalent to a plus equals 1. So it's an even shorter compound assignment operator where the value that we're adding, the value that we're subtracting is always 1 with plus plus and minus minus. So if we're counting up or counting down by 1, it's super convenient to use plus plus or minus minus. So also I want to talk to you about casting. So casting is just the conversion of one data type to another, and that's also called type conversion. So C++ will actually do this for you sometimes, and that's called implicit cast, and that's when the language performs a type conversion for you in the process of executing some code that you've written. So there are a number of rules for implicit casting in C++, a number of situations where that will occur for you. The two implicit cast rules that apply to most of your work in this class are as follows. So if you have an expression and you have two different data types in the same expression, two different numeric data types in the same expression, which is something you could totally do, the results will take on the type of the greatest precision. So if we're adding, for example, an int and a float, because the float can represent decimal numbers and the int can't, that the result of that addition will be a float. Likewise, if we're multiplying a float and a double, the double is the greater precision, so double will be the type of the resultant expression. And if we were to assign some expression to something of another data type, especially if they're numbers, C++ will attempt a type conversion for you. And there are conversions for most of the numeric data types from one to the other. So just a quick example, I have 3 variables. I have two ints, var_int1 and var_int2. They're equal to 3 and 4 respectively. And I have a var double. It's just a double variable. So I'm going to add var_int2 and 0.5. The correct answer is 4.5 mathematically, but I'm assigning it to var_int1. That's an integer, and integers can't represent decimals. So it's not going to round up. The automatic conversion in C++ from a floating point type to an integer type is it just shaves off the decimal part. Even if it was 0.99999, it would just discard the entire decimal part and leave only the whole number part. And so just to illustrate rule 1, we're adding variant 2 to 0.5 again. But this time we're assigning it to that var double that I declared above. And so as we covered before, variant 2 plus 0.5, because 0.5 represents a float type, has the greater precision, the entire expression will be a float type. And so we're able to express the 0.5 in this double data type. And so it has the answer that we expect. Something that you might not expect is when we run into integer division, which is a case when all the operands of an expression are integers, the expression result is an integer. And that's just an application of rule 1, okay, above, where there's no escalation of precision here. It's all the same type. And so students run into this especially in the especially common situation where we're dividing two integers and we're expecting a decimal result. So we want to assign the quantity 4/5 to var double, and it should be able to represent a decimal number with our double precision floating point. But that's not what happens. The correct answer is 0.8. We get the result 0. Why? Because the expression 4/5, in that expression, 4 and 5 are both integers. And so 5 doesn't go into 4, and so the result of that integer expression is 0. It's discarding that 0.8 because we're having this is an integer expression. And so it's going to assign, after that expression is evaluated, we get the value 0, and so we assign 0 to var double. And so that's just something to be aware of. So how do we fix this? We can fix this with an explicit cast, which is when we don't rely on the machine to infer, what type to convert to, that we're going to force a type change here. So we know this 4/5 is integer division, but if we take the name of the type we want to convert to and put it in parentheses, it's going to, whatever follows this syntax here, the type name in parentheses, will be converted to that type. So 4/5 will become a float data type, and we're able to express the 0.8. If you don't remember that, you can just use the decimal 1 trick, where if you have an expression that's all integers, but we want to express it as a float, the quickest way to make that a float is just to multiply it by 1.0. 1.0 is a float, but it doesn't change the value of anything else in the expression, and it forces C++ to make this implicit type conversion for us. So either of those are going to give us the 0.8 result that we expect. So thanks for watching my video. You can contact me at this email address or talk to your instructor or TA. Probably get a faster response that way. Have a good day.